Your facade inspection wouldn't be complete unless you looked at the roofing. Most of the water that gets into a facade enters in either through the top of the parapet or the flashing between the roofing and the parapet. And this is a chart here of the different common types of roofing material that you run into. At one time, built-up roofing dominated the market. However, with the increased cost of oil and oil crises, that opened the door to some other materials. Modified bitumen is a plasticized modified bitumen. Comes in about 3-foot wide sheets. Very similar to a built-up roof, but takes a little bit of the quality control out of it and the labor. You can produce a really good roof, 2-ply, that's puncture resistant. And then also with the advent of increased oil prices that opened the door to what was previously more expensive forms of roofing, such as EPDM and PVC. And you can see that EPDM is still fairly popular. Later in the 90s, a product called TPO, which is kind of a combination of EPDM and PVC, has elements of both. It's not a very proven product, and it's continually being improved because it's showing premature deterioration. However, it's a very popular product because of the pricing. It probably costs about the same to produce as PVC, but through aggressive marketing and a pricing structure, it's become a very popular roofing material. And the reason why, as you can see, here's the cost per square foot. This is taken from RS means. Of course, it needs to be adjusted for your local market conditions, but you can see the built-up roofing is the most expensive, followed by modified bitumen, EPDM. Ballasted EPDM roof is very economical. It's not near as puncture resistant as, say, modified bitumen or a built-up roof, but it's very economical. However, in this condition here, it has a ballast. The ballast is good because it protects the membrane from ultraviolet exposure. But you can see here that PVC and TPO are also very competitive as far as cost. I mentioned the parapet and the interface between the roofing and the parapet are the primary sources of water within the facade. On the left-hand picture here, you can see where the sealant has not been maintained. Not only is it reverting back to its original constituents, it's got cracking. You actually got a big piece missing here. And of course, water is going to just penetrate directly into the facade that causes problems within the facade. On the right-hand side, you've got some flashing for a built-up roofing membrane that is slipping and creating these cracks in the built-up roofing that allows water penetration. Unfortunately, I see this condition all too often. This is ponding on a roof. Ponding is defined as standing water after 48 hours after a rain event. And roofing is really designed not so much to be waterproof, just water resistant, and it's based on shedding the water and not holding it. In fact, if you pond water on a roof, you're going to violate your roofing warranty. Water also will find its way into your roofing membrane. It also will degrade asphalt and polymeric materials. And then if it freezes, it'll break loose any surface aggregates you have. Built-up roofing, as I mentioned, it used to dominate the market. It was invented in the 1840s. Now it's less than 6% of the market. It's a 4-ply asphalt impregnated felt system that's hot mopped. Earlier systems had asbestos. So if you're replacing a very old roof, you need to or maybe a roof that's been re-roofed, when you take a core, you need to check it for asbestos. This is a very common deficiency in built-up roofing when moisture gets underneath the surface. It's called blistering. As I mentioned earlier, when liquid gets heated and turns into a vapor, it expands 1,500 times its original volume. There's no stopping it, and so an older built-up roof might look like a lunar landing practice field with all these bubbles. So blistering is the #1 cause of deficiency in a built-up roof, followed by splits. And here you can see some slippage in the flashing and caused splits in the flashing that allowed water penetration into the wall. Modified bitumen was introduced into the market in the 1960s. It's a 2-ply plasticized asphalt sheet that's either torched down or mopped or self-adhered or a combination of those. Very good, tough, durable, thick material. And however, its common downfall is defective lap seams. To have a proper lap seam, you want to actually see asphalt bleed out of this joint about 1/4 of an inch, and you can tell that there's no bleed at all on this. And you can uncover this defective lap seam with a probe. In this case, someone was able to just stick their finger in there. EPDM material, essentially it's the same material that inner tubes are made out of. It's okay if you're not walking around. It's not very puncture resistant. The most common deficiency is lap seam failure. What happens is during the manufacture of these, and the rolls come fairly wide, they could be up to 20 feet wide. And what happens is when it's manufactured, the rolls are compressed and the EPDM is stretched out. And if you don't unroll the EPDM and let it sit there for a little while and regain its original shape, you're going to have tension on your joints. So when you adhere the joints together, you've got this constant pulling at those joints, and that's the #1 mode of failure in EPDM roofing. PVC was developed in the 70s. Basically, it's polyvinyl chloride and in a scrim fabric reinforcing. It does have thermally welded seams, which is a positive. The seams are said to be stronger than the material itself. However, at colder temperatures, it becomes brittle, and you can also have a breakdown of the plasticizer coming off of the reinforcing. And here on the lower left, you can see where the plasticizer is gone and the reinforcing is left. TPO is a newer product. It was developed in the 90s. Premature aging has been a big problem. As a result of that, manufacturers are continually trying to improve upon the formulation for TPO. Erosion, which you can see here, the plasticizer got washed away from the reinforcing. Cracking, seam failures are an issue. It's the newest unproven roofing material. However, it's pretty popular based on price. Roof inspection. Facade inspection would not be complete unless you looked at the roof. There again, your building engineer is a source of valuable information about when the building was re-roofed or recently repaired, work that was done on the roof recently. You're going to start out doing a visual inspection, followed by a moisture survey. Moisture survey is typically done with a thermal camera. And then verified with some moisture meters. You generate a report and produce an estimate on making the repairs in order to make your facade watertight and last longer. when you're doing your investigation, it's always helpful when you have somebody point out where the leaks are. Saves you a little bit of work. Just seeing if everybody's paying attention at this point. It goes to show you that you don't have to know how to spell in order to find a roof leak. A visual inspection, you'd be looking at the underside of the roof, looking for rusting deck perhaps, water leaking in. You're going to look at the top side of the roof. You're going to look for debris, problems with drainage, clogged drains, membrane deterioration, tears, maybe adjacent to a rooftop equipment. You might look and see if people left fasteners that they maybe stepped on and punctured the roof. And then you do a moisture survey, as I mentioned, from above as well as below, using thermal imaging, and then verify the anomalies that you see. Drones have revolutionized the roof inspection business. It used to be the best way to inspect a roof was from an airplane, which is kind of impractical. The alternative was a handheld thermographer, and you're looking at an angle, and you can see actually thermal reflections off of adjacent surfaces. Up above, looking straight down, this image on the right is a drone that is just taken off, but you typically would fly that up high at dusk, which requires special waivers. And what you're looking for is the insulation and moisture within the roof will heat up during the day. So you want a nice, hot, sunny day. And then at night, at dusk, the insulation cools off very rapidly, while the wet insulation cools off very slowly. Here you can see a typical image taken from our drone. The visual or red, green, blue image on the left is a normal image. You can see dirt on the roof where you might have had ponding and there's kind of debris settling there. So it's kind of signs of water, the presence of water, at least in a visual sense there. On the right-hand side, you'll see the red hot areas. Those are areas where you have wet insulation, and they show up a lot hotter toward the end of the day, especially at dusk. What you see in a thermal image is a reading of surface temperature. So all you're getting are anomalies, areas where the surface temperature is different from adjacent areas. They typically are indicative of the presence of moisture, but because they're anomalies, they need to be confirmed through testing. On the left-hand side is an impedance meter. It's a non-destructive test method to determine if there's moisture beneath the roofing. On the right-hand side is a pin-type meter, a little bit more accurate. It checks the electrical resistance between two probes, and you can easily plug those two holes after you're done. The most thorough test is by taking a roof core. Of course, you wouldn't want to do this on a warranted roof without the roofer being there, but you can determine the entire buildup of the roof. You can tell if it's been re-roofed. You can see if there's asbestos in the roofing felts. You can also take the core and put it in a Ziploc bag, take it back to the laboratory, weigh it, cook it in the microwave, and weigh it again. You can determine what the moisture content is. So we looked at how to conduct condition assessments of both the facade and roofing. And the last part is to put together a report. Now our reports are pretty thorough. We want to make it a permanent record. We'll describe the entire building construction, all the different systems, at least structural and architectural systems, any renovations that took place, any additions. We'll talk about the general condition of the building, overall condition, and then we'll identify the deficiencies, how bad they are, how quickly they need to be repaired. We'll talk about the waterproofing system. We will locate all these deficiencies in elevation views and photographs. And last but not least, we will provide an estimate To me, a report without an estimate is hardly of any value because usually the next logical step is you're going to want to do a repair and you need to know how much budget to carry. Continuing on the classification of deficiencies, this is from the ASTM standard. You have an unsafe condition which has to be addressed immediately. You need to notify the owner while you're still on site or the building jurisdiction, depending on where you're located. Requires repair stabilization is something that needs to be repaired before the next inspection. And then ordinary maintenance are items that need to be repaired as part of your next scheduled maintenance. So we talked about the importance of inspecting your facade and envelope. And also we showed you some examples of what can happen when you have a facade failure. So that's basically why you want to inspect your envelope and facade from a liability standpoint. We looked at the behavior of different facade materials, expansion, contraction, things of that nature. And then the inspection process of both facade and roofing. And then last but not least, we touched on reporting and how to put together a thorough report. With that, normally I would open the floor up to questions, but this being a recorded webinar, I can offer my email address and phone number. And if you should have any questions that you'd like to have answered, please contact me and I'll do my best to provide you the most complete answer that I can. And since we're at the end of our presentation, I want to thank you for attending and enjoy the rest of the day. Thank you.